as far as graphing a line, so here are like the instructions to graph a line. I would say 1, plot the y-intercept. 2, plot another point. And if you have an x-intercept, that is the other point you should plot. And it's usually going to be the intercept, the x-intercept. And then draw the line between them. May I see your symptom survey, please? Sir? Okay. So let's look at this other line here. We had, what was it? Y equals negative 3 halves x plus 4. And let's do that one in red. So y equal to negative 3 halves x plus 4. We're going to find the y-intercept. We're just going to set x equal to 0. This has to be a little bit higher. There we go. When we do that, we're going to get y equal to 4. So we're going to get the point 0, 4. Thank you so much. And for the x-intercept, we're going to set y equal to 0. And that's always going to be the one that's a little more work. Oh, sorry, I'm off the page there. Or sorry, I thought I saw a question, but maybe I'm just imagining things. Also, I really feel like I don't love that I'm like looking at this like this, but I guess that's what we've got. So y equal to 0, and we're going to solve for x. So I'm going to have, let's see here, 0 equal to negative 3 halves x plus 4. Thank you. So then we have positive 3 halves x equal to 4. And then multiplying both sides by 2/3, we're going to get x equal to 2/3 times 4, which is 8/3. Graphing 8/3, not a super exact process, right? It's somewhere between 2 and 3. It's a little bit more closer to 2. It's probably about right there. This is a time where I might graph a third point because there's an easier third point to graph. So I might be like, well, if I let x equal 2, then negative 3 halves times 2 is negative 3, and negative 3 plus 4 is 1. So I can also have the point 2, 1, which might be a little bit easier. So you definitely should still plot the intercepts. But if you're trying to make your graph as nice as possible, again, I don't super care about, but just trying to point out some people really care. We can plot that other point there. And there's our line y equals negative 3 halves x plus 4. Yes. Yeah, so the blank worksheet or the completed worksheet? Yes, I was just waiting to post it until after I completed it. But I think there is an older completed one that is already posted on campus. But yeah, so I'm pretty sure, I'll double check that. I think I've already posted all the completed notes. And I mean, really, it does feel kind of silly. We're just kind of doing the same work again that's already on there. But I know that it's not really silly because it's good to see someone talk about it and have a chance to ask questions. But yes, so yeah, I apologize if it's hard to see. I don't think there's anything I can do to make it look better. So sorry. But yes, I would. So that actually brings up a good point. If you want to follow along on a laptop, you could actually have Zoom up and see this on your computer. That is also perfectly fine. Really, you don't have to take these notes. I think it's a good idea to take them. It's not required in any way, shape, or form. They're all very available to you. So what I'm trying to say is do what's best for you, right? If having your laptop up and either looking at the notes that are posted or logging into Zoom and looking at what's on the screen a little bit closer to your face, totally fine. I don't mind at all. All right, let's move along. Finding the equation of a line passing through 2 points. So to find the equation of a line, you need 2 pieces of information. You need a slope. Oh, I definitely can. Or I can actually probably prefer. You need a slope and you need a point. we already have a couple points. We have the points -3, 1, and 4, 5. So we're good on that front. To find the slope between 2 points, we're going to use the slope equation. And that's going to be, typically we use the letter m for slope. It's the difference in the y values divided by the difference in the x values. And it's really important when you do the subtraction, you subtract in the same order. So if I'm picking, say, this y value first, 5 minus 1, then in the bottom, I have to pick this x value first. I have to pick 4 first, because 4 and 5 are one set of coordinate points, and -3, 1 is another set of coordinate points. And that's going to be 4/7. It doesn't matter which one you call x1, y1, which one you call x2, y2. We could have done it as 1 minus 5 over -3 minus 4. And that would have also been perfectly fine. And we'd still get the same slope. Either way you want to do, just so long as you keep things in the right order. And then there's a couple different ways to go here. My preferred way of doing it is the following. I'm going to use what's called the slope, sorry, not like, what do you call this form? The point slope form, where you do y minus the y coordinate equal to the slope times x minus the x coordinate. That's usually how I like to do it. So I'm going to pick either point, doesn't matter which one. Let's pick this first one. And we'll do y minus 1 equal to 4/7 times x minus -3. So usually we isolate y because that's kind of the standard way of writing the equation of a line. So if we do that, we're going to get y minus 1. I'm going to distribute this 4/7 and get 4/7 times x, and then 4/7 times +3, which is going to be 12/7. And then I'm going to add 1 to both sides to isolate y, and that's going to give me y equal to 4/7 x plus 12/7 plus 7/7 is 19/7. Alternatively, really like a blank piece of paper. It's over here. So another way you could do this, I'm going to write over here because I don't have it on this page, is you could also do it the y equals mx plus b way. Say, well, I know what the slope is already, y equals 4/7 x plus b, and then you can pick either one of those points and plug in those values for x and y. So I'm going to use the other point. If I plug in x equal to 4 and y equal to 5, I get 5 equal to 4/7 times 4 plus b. And then 4/7 times 4 is 16/7. And 5, I should multiply by 7/7 to think of as 35/7. Then I have 35/7 minus 16/7 equals b, and that's exactly 19/7. So then we can take that value, throw it back in there. Say, oh yeah, we get y equal to 4/7 x plus 19/7. Either way you do it will result in the same value of b, right? Either way, we got 19/7. The one reason I like doing it this way slightly better is because when I'm done with the problem, I've got it written the way I want it. Whereas this way, once you solve for b, then you have to kind of go back and plug it back into the equation. So I just feel like there's an extra step here that I don't always love to do. But either way, it's fine. Some notes about slope. If two lines are parallel, their slopes are equal. Or the same. Some examples: y equal to 2x plus 5 and y equal to 2x minus 18. Or even, this one's going to look a little bit different, 6x minus 3y equal to 8. Here you can't see the slope as easily, but this does have a slope of 2 as well. And we could see that if we solve for y. Welcome. Thank you. Oh, something in the chat. Let's take a look. Will the answer be the same if we switch the place of the X 1 and 2 and the Y 1 and 2? I'm not sure if what you're referring to. I'm sorry, Eve, I'm not sure which question you mean.
For the one we just finished, like, yeah, so for like the points 1 and 2, like x1 and x2, can you like flip-flop them for any equation and still get the same answer, or was it just for like this equation was like a coincidence?
Most of the time it's all right. Really, we're just, so what I did was I called, this point here x1 comma y1, and this point here x2 comma y2. But it wouldn't have mattered if I'd called them the other things. Right? If I called this one x2 y2 and this one x1 y1, we'll still get the right answer either way. And I would say most of the time that's pretty true. If you're talking about an equation like the distance formula, for example, and you're finding the distance between 2 points, it doesn't matter which one you call x1, y1, and which one you call x2, y2. They're each playing a role, they're interchangeable. Perpendicular lines, on the other hand, have opposite inverse slopes. So, for example, y equal to, what are my examples here? My examples are way too far away. Oh, so not that close, come on. For example, y equal to -3 halves x plus 17, and y equal to positive 2/3 x minus 5. These lines have slopes that are reciprocals of each other or inverses of each other, and they're opposite signs. Yeah.
Going back to the first question, how much work do you care about showing? Like, for example, do you want us to show how we like distribute the 4 sevens, or can we just put like 12 sevens like we did?
Oh, that'd be fine. Yeah.
Okay.
Yeah. So I'm generally trying to demonstrate the amount of work I would expect to see, but that's a fair question. I try to be as, if I can read what you've done and it doesn't look like the giant leap between one step to the next step you're doing, like it's the problem is it's not a very precise answer, right? Like it's kind of depends. If it looks like it's a reason, like I'm like, oh yeah, I can see how they totally got from there to there, but it's kind of like, how did they get all the way from there to there? Which I know is very specific, not really. I'll try to give you feedback on homework assignments. So certainly in the beginning, you're like, oh yeah, you need to show a little more work, or you're showing way too much work. That's great, but you don't have to show so much. So I will try to do that for the first few assignments, so you can kind of know what's going on that way. Some other notes about lines. The equation y equals c is a horizontal line, and notably, it won't have any x-intercepts unless it's the line y equals 0, and then everything will be an x-intercept. Usually no x-intercepts. In the same sort of way, the equation x equal to c is a vertical line. Usually there are no y-intercepts. So when I'm thinking about graphing either one of these, the equation y equal to c, I'm usually going to plot the point 0, c on the y-axis and then just draw the horizontal line through it. In the same sort of way, for the equation x equal to c, I'm going to plot the point c0 and draw the vertical line through it. I should also mention horizontal lines have a slope of 0. If you're thinking about the slope being the rise over the run, which is often what we say, a horizontal line has no rise and a lot of run. So if you have 0 rise over a lot of run, 0 divided by anything that's not 0 is still 0. Right? 0 divided by 5 is still 0. On the other hand, vertical lines have an undefined slope. Here, for a vertical line, the rises infinite, or really any value you want, but the run is 0. So when you divide by 0, that's when things go back. Undefined. Excellent timing. And this is, I feel so really great with this whole situation here. It's really nice. Like, okay, so we're just covering some basics of lines. Let's talk about parabolas now. Lines should be pretty straightforward. Graphing them, 2 points, finding the equation of them, slope, point. There's not a whole lot. I mean, you could talk about lines for probably 2 days solid if you really wanted to, but like, lines are lines. Very, very useful. Parabolas. There's 2 different ways we like to write them. Either y equal to ax squared plus bx plus c. That's kind of the, I guess, the general form. And then we also have y equal to a times x minus h squared plus c. Sorry, plus k, not c. And a few things about these. And one, in each of these equations, the a value is the same. So what I'm really trying to say here is, like, you could write the equation for the same parabola in either one of those ways, and the a value would end up being the same whichever way you go. The other thing is, so much like the slope-intercept form of a line tells you the slope and the intercept, this form here, which is often called the vertex form of parabola, shows you what the vertex is. So this is the vertex form. And the vertex is the point h comma k. When I think about parabola, if it's opening upwards or opening downwards, let's say it's opening upwards. So actually, before we get there, let's say that. So some notes about A. If your A value is positive, which we're just going to write as A being greater than 0, then the parabola opens upwards. Like this. Up like a cup, as I often say. On the other hand, if A is negative, less than 0, the parabola opens down. Down like a frown. Oops, you can't see that. This thing is not quite big enough. Okay. The reason we can, or the way we can justify ourselves that HK is the vertex here is if this, so let's say A is positive and the parabola is opening upwards. If the parabola is opening upwards, then the vertex should be the lowest point. To find where this is going to have the smallest y value, right? The lowest point is going to have the smallest y value. You want it to be as small as possible. And the way to make this quantity as small as possible, well, if A is positive, x minus h squared is also non-negative, I should really say. The way you're going to make this part the smallest is by making this part here 0. To make that 0, x has to be h. So that's the whole idea. If x is h, this part's 0, and the whole thing is as small as possible if it's opening upwards, or if it's opening downwards, it's as large as possible. So that's why this form shows us where the vertex is. I will say the downside of this form is it's more work to find the y-intercept. You actually have to plug in 0 for x and then calculate subset length. Whereas this form here, it's very easy to see the y-intercept is just the c value. So some forms have positive things and negative things. There's ups and downs to each thing, I guess is what I'm trying to say. And so you guys, just let me know if there's something in the chat that I missed, because it's easy for me to miss the chat. Let's graph a parabola. And here is what I would say as far as graphing a parabola. the first thing you always want to do is find the vertex. The second thing you want to do is find the y-intercepts. Y-intercept, singular. There is only one. And then the third thing you want to do is, well, I'm going to call this step, let's call it step 3A. Determine if you even have any x-intercepts. And then the fourth thing, or I should say the second part of that, is find the x-intercepts if you have them. And those are really the only things I think you need to find to be able to effectively graph a parabola. Let's do it. To find the vertex, there's a couple ways. I'm going to show you what I think of as the standard way, and then we'll talk about also doing it, finding the vertex form, or what's called the completing square form. I'm going to find the x coordinate of the vertex, which I label as b sub x. The x coordinate of the vertex is negative b over 2a, where we are making the assumption that this is written as y equal to a times x squared plus b times x plus c. So our a value, oh, can you not see that? Of course not. Our a value is 1, our b value is negative 2, and our c value is negative 8. So here, our x coordinate of the vertex is going to be negative negative 2 divided by 2 times 1, which is just 1. To find the y coordinate of the vertex, we're going to plug in the x coordinate back to the original parabola. So we're just going to plug in the x coordinate of the vertex. So Vy is going to be 1 squared minus 2 times 1 minus 8, which is 1 minus 2 minus 8, which is negative 9. So our vertex is the point 1 comma negative 9. Y-intercept, super easy to find here. I set x equal to 0. We're going to get y equal to 0 minus 0 minus 8. So our y-intercept is 0, negative 8. Here's the point where I'm going to pause. I'm not going to go willy-nilly looking for my x-intercepts. I'm going to plot these 2 points. Say, okay, here's my y-intercept at 0, negative 8, and here is my vertex at 1 comma negative 9. Just looking at this, you don't even have to know the a value. Does this graph have to open upwards or downwards? Got to be up, because, well, you could either say because a is positive, but you could also say because, well, the vertex is the highest or the lowest point. But clearly, it's not the highest point because there's a point that's higher than it. So it's got to be the lowest point, which means it has to open up. So once you have the y-intercept and the vertex, unless they're the same, which they could be the same, but they're usually not the same. Once you have these, you kind of know which way it's going. And you know that since it's opening upwards, we are going to have x-intercepts. On the other hand, right, if our, let's say our vertex was here and opened downwards, be like, oh, there's no x-intercepts. I'm not going to follow it. So don't try to find x-intercepts if there aren't any. Don't waste, right? Don't do more work than you need. So find the x-intercepts. We're going to set y equal to 0. So we're going to have 0 equal to x squared minus 2x minus 8. And a lot of the time, this will factor. This right side factors as x minus 4 times x plus 2. So our x-intercepts are x equal to positive 4, x equal to negative 2. I am skipping a step there, right? You could say x minus 4 equals 0 and then get x equals 4, x plus 2 equals 0, and get x minus 2. I think that's a perfectly fine step to skip. So x is 4, x is negative 2. A good check that your x-intercepts are right is they should be equally spaced to the left and right of where the vertex is. So the vertex is at +1, or I should say it's at x equals +1 and y equals whatever. And one x-intercept is 3 to the right at 4. One x-intercept is 3 to the left at -2. So good, they should be equally spaced out. Another way of saying that with less words is the vertex is on the axis of symmetry. So there should be things either to the same distance on either side. And then I will try my best to make the drawing look not terrible. Trying to make your vertex not too pointy. It doesn't have to be perfect, like mine clearly is not. Like, right, because it really should be going through that point right there, but I missed it. Oh, well, that's life. I should mention, what time is it? Track of the time. Oh, I got time. You could also do this parabola by finding the vertex form. Or also known as the completed square form. It's a little more work, and it's really, I will say, you only ever really want to do it if the b value is even. Right? If your b value is odd, completing the square is a giant pain in the butt. Yeah. Sure. So when I'm factoring something like this, as long as the coefficient of x squared is 1, it's usually straightforward. If it's not 1, it's a more complicated process. We're looking for numbers that multiply to -8 and add up to -2. And those numbers are -4 and +2. So that's kind of a very brief explanation of how I factor that. I do think we talk more about factoring later on in the course. I'm trying to remember now. I'll take a look. But yeah, but also I have office hours after class today. Happy to talk about factoring a lot if you want to. The other way you can do this is by what's called completing the square. So if we look back at y equal to x squared minus 2x minus 8, the way you complete the square is by taking this coefficient of x, which is -2, dividing it by 2, and squaring it. Let's see, -2/2 is -1, -1 squared is +1. So I'm just going to add that in. But you can't just add that in. If you add something in, you also have to subtract it off. So that I didn't really change anything, right? Still the same equation. I just added 1 and subtracted 1. Why would I do that? Because then this part here factors as x minus 1 times x minus 1. Or in other words, as x minus 1 squared. -1 minus 8 is -9. And now you can kind of see there's the, oh, you can see at the bottom of the board the vertex form, which shows you that the vertex is when x is 1, y is -9, which is exactly what we got. Yeah.
So is the -1 typically like the opposite of what you get for vertex? Like you got 1.
Right. So and that's actually a good point. Whenever you complete the square, you're always going to be adding on a positive number. Right? There's always something divided by 2 and then squared. So you're always going to add on a positive thing, and then you're also going to subtract it right off. So that it's really just the same equation, it just works a little different. But yeah, that's yes, it's always you're always going to add that there and then subtract it off there. Anything else I want to say about this? I don't think so. Other questions about this though? Like I feel like there's something rattling around my brain that like I really want to say about this, but no, I guess not. So I would encourage you all to graph it this way. Like completing the square is nice. It shows you some cool things. You can find x-intercepts in kind of a neat way by completing the square. But it's only really nice if the coefficient of x is a nice even number and the coefficient of x squared is 1. If you have other sorts of parabolas, it becomes a lot more of a challenging process to complete the square. So usually we use completing the square more when we talk about equations of circles. Let's see, make sure it's the same thing I'm missing here. Yeah. So let's look at these two equations. Y equals -x squared plus 6x. And, oh, sorry, of course, yeah. y equals negative x squared plus 6x, and y equals 2x plus 3. And if I was looking at this before you like, and it says find their points of intersection effectively. And when I look at this, I'm just immediately kind of thinking, okay, that's a parabola, opens downwards, that's a line. I mean, I'm just thinking about the things they're going. So I want to find their points of intersection. I'm going to do that by setting the equations equal to each other. Bless you. Almost, I guess. I hate those abbreviated sneezes, they're the worst. So I'm going to set 2x plus 3 equals to negative x squared plus 6x. And then whenever I'm trying to solve an equation, unless it's a linear equation where I only have x to the first power and no other powers of x, in that case, I would just solve for x. I can get x by itself, done. And this sort of thing where you have different powers of x, or what's called a nonlinear equation, you typically need to bring everything to one side of the equation so we can do some factoring. So I'm going to bring everything to the left, or more generally, I'm going to bring everything to the side that's going to give my highest power of x a positive coefficient. So I want to bring everything over to the left so that x squared is a positive x squared. So then I'm going to get x squared, and then 2x minus 6x is minus 4x plus 3 equals to 0. So I added x squared to both sides, I subtracted 6x from both sides. And now that we have everything equal to 0, which is really important, right? Equaling 0 is a big bonus for us because when you have things that equal to 0, if they multiply to 0, each factor gets to be set equal to 0. So I'm trying to factor this, and I'm looking for things that multiply to positive 3 and add up to negative 4. And there's really there's only two ways to multiply to 3, 1 times 3, or negative 1 times negative 3. And it's got to be negative 1 and negative 3 because those are the ones that are going to add up to negative 4. This is going to factor is x minus 1 times x minus 3. So what are I won't say what are our solutions to the question, but what are our solutions to this equation? X equal to what and what? Yeah. Now, I point out that's not the answer to the question, because the original question said, find the point of intersection. And the x value doesn't represent the entire point. Right? The x value is the first half of the xy coordinate. So I need to go back and use either one of these equations to find the corresponding x or y coordinates for each of these x coordinates. So for x equal to 1, either one should be fine. I'm going to use this one. I'm going to get y equal to 2 times 1 plus 3, which is 5. So this gives me the point 1, 5. And then when x is equal to 3, I'm still going to use that one. I'm going to get y equal to 2 times 3 plus 3, which is 9. So I get the point 3, 9. So those are the points where this line and this parabola should intersect each other. So let's sketch the graph of both of the equations on the same axis below. All right, so we should really, so even though we know where they intersect, which is at 3, 9 and 1, 5. Well, that's enough for the line. I'm like, if I was drawing this line, I'm not going to draw it. Y equals 2x plus 3. I would still do the usual things, meaning I would still find the y-intercept by setting x equal to 0, and getting y equal to 3. And I would still find the x-intercept by setting y equal to 0, getting 0 equal to 2x plus 3, negative 2x equal to positive 3, x equal to negative 3/2, or negative 1.5. Now I know I have way more points than I actually need to graph a line, but I still want the intercepts. Here is my line. Okay, that's fine. My lines always feel like they look not super straight. Okay. Parabola, y equals negative x squared plus 6x. We're going to find the usual things. We're going to find the vertex. I should say we're going to start with the x coordinate of the vertex, which is negative b over 2 times a, which is going to be negative 6 over 2 times negative 1, which is going to be negative 6 over negative 2, which is positive 3. And the y coordinate, v sub y, I'm just going to plug in 3 back to that parabola equation. So I'm going to get negative 3 squared plus 6 times 3. And this is a place where people always sometimes get a little caught up. Negative 3 squared is negative 9. There's no parentheses here to indicate it's not quantity negative 3 squared. It's 3 squared and then the negative comes after, right? So if you think about order of operations, good old PEMDAS, parentheses, exponents, multiplication, divide, add, subtract. So the exponent you do before the subtraction over here. On the other hand, if it was negative 3 quantity squared, that's negative 3 times negative 3, which is 9. But this is negative 3 times 3. Plus 18, which is negative 9 plus 18, which is positive 9. So, sorry, brain. Oh, yeah. So interestingly, the vertex is the point of intersection here. 9. Y-intercept is going to be, let's see if I set, so if I set x equal to 0, I'm going to get y equal to 0 because it's a 0 plus a 0. Okay, and I guess I should also find the other x-intercept. So x-intercepts, set y equal to 0. We're going to get 0 equal to negative x squared plus 6x. And here's something I should say about this. People, for some reason, have a hard time factoring this sometimes because they're looking for like the usual kind of quadratic factoring. But this one is actually even easier, right? Because each of the terms, negative x squared and positive 6x, have a common factor you can just pull out. Right? If there is no constant term at the end, no plus c, you can almost always just factor out an x. And then we're left with 0 equal to x times negative x plus 6. Or if you prefer, you could have factored out a negative x and said it was negative x times positive x minus 6. Either way, we're getting x-intercepts that are x equal to 0 and x equal to positive 6. All right, and now the hard part. We try to make the graph look semi-nice. We know we need to hit this point here because that's the point of intersection and that point here. Here's what I'll say. Since I know I've got this point here, which is 2 to the left of my vertex, I'm also going to have a point at the same height, 2 to the right of my vertex. You can use that kind of symmetry fact about parabolas. You know you have a point at a certain height. You know you have a point reflected across the axis of symmetry at the same height. Not too bad. Okay. Okay. Couple extra problems. There was something I wanted to say. I don't have an example of it. Let me just write it down here. Oh yeah. I wanted to mention, since I don't have an example of it, but maybe we'll do this one. Just as an observation, y equal to x squared plus 2x plus 3. So I was like, I know I'm writing too high. Has no x-intercepts. So if you were graphing that one, you would just find the vertex and the y-intercept and then graph the parabola. And maybe, I think we might have enough time to actually do that one. So we might just do that one together. Let's do a couple more problems. It's good to practice. Let's find the equation line passing through 2, -5 and perpendicular to y equals -3 halves x plus 17. So we're being asked to find the equation of a line. We need two things, a what and a what? A slope and a? That is correct, but you can be more general. So instead of specifically having the point that's the y-intercept, really Any point will do. So as long as you have a slope and any point, you can find the equation of the line. But we definitely have a point. And the slope isn't immediately obvious to us, but it's not so far-fetched that we can't see it pretty quickly, right? If our line is perpendicular to y equals negative 3 halves x plus 17, then our slope should be what positive number? Sorry, I didn't quite hear that. Thank you, yeah. Right, it's just the negative reciprocal of this slope here. So 3 halves becomes 2/3, and we change the sign from negative to positive. And then we can find the equation. It's going to be y minus the y coordinate equal to the slope times x minus the x coordinates. Or if you prefer, you can do it the y equals mx plus b way and plug in the point, -5 equal to 2/3 times 2 plus b. Either way will get us to the same place. I'm going to do it this way. On the left, I have y plus 5. On the right, I'm going to distribute the 2/3 to get 2/3 x minus 4/3. And I'm going to subtract 5 from both sides, but 5 is really 15/3. So I'm going to subtract 15/3 and get y equal to 2/3 x. -4/3 minus 15/3 is -19/3. Or you can do it this way. -5 is -15/3 equals 4/3 plus b, and then subtract 4/3 and you get 19/3. And then you would plug that back in there. If you do it this way, you do need to actually go back and write out the equation y equals 2/3 x minus 19/3 is your equation for y. Either way is really fine. I just like doing it better this way. And let's actually, yeah, time is it? We got time. Let's go ahead and graph this by using the method of completing the square, which I know we already did an example of, but let's do more examples. I kind of want to do this one though, just to show you. Let's do this one instead. So instead of this one, you can look at the notes. It's in the notes. Let's do it. Go ahead. Oh, I know. I'm sorry. I've been going back and forth here. Let's do this one because it shows us the thing. So completing the square. So can somebody tell me what number we're going to add here so that we can complete the square? Well, we're going to add it and subtract it. What is that number?
4.
Yeah, it's 4. And the way you're getting that, I'm assuming, is by taking -4, dividing it by 2, and then squaring it. That's the whole deal. It's always the coefficient of x divided by 2, quantity squared. Excuse me. So this is going to become y equals x squared minus 4x plus 4 minus 4 minus 5. And now there is kind of a, yeah.
What do you do when the first 3, like the quadratic part of it, like what if it doesn't pass it?
That's a good question. Yeah, that so.
I'm just asking.
No, no.
The homework and it's due Monday.
Right.
And that's
So
how
no, so there's two. In fact, yeah. Let's actually address. That's a better question. Why don't I have any blank paper? Kind of insane person comes to a class without blank paper. There we go. Okay. There's kind of two situations of not factoring. There's something like this. Y equals x squared plus 2x plus 3. And then there's also something like this. Y equal to, let me think for a second here. Y equal to, let's try x squared plus, I want it to be not too terrible, 5x plus 2. Okay, so both of these examples don't factor, but they're different. So this first one, my vertex, the x coordinate would be -2 over 2 times 1, which is -1. the y coordinate would be -1 squared plus 2 times -1 plus 3, which is 1 minus 2 plus 3, which is 2. So my vertex is -1, 2. And my y-intercept is 0, 3. And we start graphing that. There's my vertex. There's my y-intercept. Do I have any x-intercepts? Yes, no, maybe. So is the vertex the highest point or the lowest point? Lowest, right? Because, well, one, you know it's opening upwards, but two, there's a point above it, right? The vertex is that one there. There's your y-intercept that's clearly higher than it. So it can't be the highest point. It's got to be the lowest point. And if it's the lowest point, there are no x-intercepts. So this one, if I was graphing this one, I would probably plot one more point. I go over 1 and up 1. I also go over 1 and up 1. Or as I like to say, I like to mirror the y-intercept across the axis of symmetry. The axis of symmetry being x equal to the x coordinate of the vertex. Question? You can make a table, and you're welcome to make a table. What I'm trying to show you is, in my opinion, what is the most efficient way of graphing it. So I don't require a table from you whatsoever. All I need to see when you graph a parabola is the vertex, the y-intercept, and the x-intercepts if there are any. This one doesn't have it. Now, so what I wanted to address the question about factoring, it doesn't matter that this one is a factor because we're not going to try and solve it equal to 0 because we already know there aren't any x-intercepts. And I will mention that if you try to solve this one equal to 0 using the quadratic formula, which we'll talk about in another class, you would get imaginary solutions, which means there aren't any x-intercepts. So you have a square root of a negative number. On the other hand, this one here, I picked a fraction. Oh, well, so I might need an extra minute here. The vertex, if you need to go, you're welcome to go in 30 seconds. If you can stay though, please do stay because this will only take a moment. Here, the x coordinate of the vertex is -5/2. I'm just going to leave that way. The y coordinate of the vertex is going to be -5/2 squared plus 5 times -5/2 plus 2. And doing some math, I get 25/4 minus 25/2 plus 2, which becomes 25/4 minus 50/4 plus 8/4, which is, let's see, 25 plus 8 is 33, minus 50 is -17/4. And the y-intercept is going to be 0, 2. So if I look at where things are, oh yeah, thank you. So my vertex is over here at -2.5, -17/4. -17/4 is a little more negative than 4. And my y-intercept is over here at 0, 2. Am I going to have x-intercepts? Yes, right, because my vertex is way down here and it's got to open upwards. So if my vertex is below the x-axis and it opens upwards because my a value is positive, or because you can see the y-intercept is above it, you're going to have x-intercepts. So here we are going to have x-intercepts, but you're right. If we try to solve x squared plus 5x plus 2 equal to 0, it doesn't have any factoring. At least I should, well, here's what I should really say. It doesn't factor in the nice way we're used to things factoring, meaning there aren't two integers that multiply to 2 and add up to 5. Technically, you can still factor this. It just looks like garbage. The way you want to solve this is by using the quadratic formula. So my x-intercepts are going to be x equal to -5 plus or minus the square root of 5 squared minus 4 times 1 times 2 all over 2 times 1. Which if we simplify just a tiny bit is -5 plus or minus the square root of 25 minus 8 is 17 all over 2. And so what I will say here is, oh, that's interesting. That's what Duff was saying. Oh. Sorry, I just saw something that's like kind of cool, but is yeah. So I will point out square root of 17 is just a little bit bigger than 4, right? Like, I don't know what it is. It's a little bit bigger than 4 because the square root of 16 is 4. -5 plus something a little bit bigger than 4 is not quite positive. So I'm going to use a very small negative number over 2. And then -5 minus something that's like 4 is going to be -9-ish over 2, which is like -4.5-ish. So here's -1, -2, -3, -4. So like about there. You don't have to be super exact, but that's how you would find those x-intercepts. So the x-intercepts are there and there. That's a good question. Thank you for asking that question. That really, I think, was very illustrative for all of us. So thank you.